So we're looking at question number 4 of the thermochemistry worksheet for homework. So we're taking 50 grams of ice at negative 15 degrees Celsius to steam at 120. So really we're starting down here at negative 15 and going all the way up here to 120. So we're gonna have to do all 5 steps. So for this first step, we're trying to find how much energy it takes to heat my ice from negative 15 to 0 degrees. So we're going to take the mass, 50 grams, multiply it by the specific heat of ice, 2.1 joules per gram degree Celsius. Then by the temperature change, so because this is negative 15 degrees to 0, 0 minus a negative 15 equals 15 degrees Celsius. So we get 1,575 joules. Next, we're going to go through the phase change. So we're going from ice to liquid. So we have Q equals the mass of our substance, 50 grams, times the delta H of fusion, which is 334 joules per gram. And we get 16,700 joules. Next, we need to heat our water from 0 degrees to 100 degrees. So 0 to 100. So Q equals the mass of our water times the specific heat of water, 4.18 joules per gram degree Celsius. Times the change in temperature. So we're going 100 minus 0, so we get a temperature change of 100 degrees Celsius. So 20,900 joules. Step 4 is a phase change from liquid water to steam. So we take Q equals our mass, 50 grams, times the heat of vaporization, which for water is 2,260 joules per gram. So we get 113,000 joules. Now we have to look at our water from the steam at 100 degrees all the way up to 120 degrees. So Q equals the mass of our water. The specific heat of steam is 1.7 joules per gram degree Celsius. Times the temperature change, so we're going from 100 to 120. So the change is 20 degrees Celsius. And we get 1,700 joules. Now we have to add everything up. So starting with our 1575, 16,700, 20,900, 113,000, and 1,700. We get a grand total of 153,875 joules. If we want to change this to kilojoules, we take our decimal place and we're going to move it back 1, 2, 3, so we get 153.87 kilojoules.